Hello everyone, my name is Mohammad Abdulahad and today I will be presenting my internship project which I completed as part of the WebStack Academy internship program. This presentation covers everything I learned and built during my internship, from the overview and goal through the architecture and technology stack, all the way to live demo of the final application. Let's get started. Overview. Let me start with a quick overview of the internship. I completed a 4-week internship focused on full stack web development, where I worked on building a complete web application called the AI Food Delivery app using the MERN stack. That's MongoDB, Express, React, and Node, along with AI-based recommendation layer. Over the course of this internship, I moved through the full software development lifecycle, starting with the requirement gathering and design, then moving into backend and front-end development, integrating an AI recommendation feature, testing, and finally deploying a working product. Goals of the internship. Before diving into the project itself, let me talk about the project goals I set out to achieve during this internship. My first goal was to understand full stack web development end to end, not just writing code, but understanding how a front end, a back end, and a database all work together as one system. My second goal was to get hands-on experience using MERN Stack, since it's one of the most widely used stacks in the industry today. Third, I wanted to explore how AI can be integrated into real project requirements. Now let's look at the brief requirements for the project. The goal of the AI for Delivery app was to allow users to register and log in securely, browse restaurants and menus, add items to a cart, and place orders, track their order status, and receive personalized food and restaurant recommendations powered by AI based on their past orders and preferences. On the technical side, the requirements were a responsive front end that works well on both desktop and mobile, a secure backend API to handle orders, payments, business logic, a database to store users, restaurants, menu items, and orders reliably, user authentication, and an AI recommendation module. Architecture and design. This slide shows the overall architecture of the application. At a high level, the system allows a three-tier architecture. At the top, we have the client layer. This is the React application running in the user's browser. It's responsible for rendering restaurant listing menus, the cart order tracking screens. In the middle, we have the server layer, a Node.js and Express.js application that exposes a set of REST APIs. This layer handles authentication, order processing, and also calls into the AI recommendation engine whenever a user opens the home screen or the recommendation feed. At the bottom, we have the data layer, MongoDB, which stores all our collections like users, restaurants, menu items, and orders in a flexible JSON-like document format. This same order history that also fits the AI recommendation model. Communication between the client and servers happens through HTTP requests using REST APIs, and data is exchanged in JSON format. I also use JWT JSON Web Tokens for authentication so that once a user logs in, their identity is securely verified on every subsequent request. This layered design keeps concerns separated. The front-end only worries about UI, the back-end only worries about logic and security, the database only worries about storing data, and the AI layer only worries about generating good recommendations. What is full stack web development? Before going into implementation, I want to briefly explain what is full stack web development actually means. Full stack web development simply means being able to work on both the front end and the back end. of an application. The front end is everything the user sees and interacts with directly. The restaurant cards, menu pages, cart, and checkout screens, built using HTML, CSS, and JavaScript, often used with a framework like React. The backend is everything happening behind the scenes, handling requests, running business logic, processing orders, talking to the database, and sending back responses. Usually built using a server-side language or runtime like Node.js, and connecting the two is the database, which is where all the actual data is permanently restaurants, menus, orders, and users. The MERN stack. Now let's talk specifically about MERN stack, which is the technology stack I used for this project. MERN stands for MongoDB, Express, React, and Node. MongoDB is a NoSQL document-based database. Instead of storing data in rigid rows and columns like traditional SQL database, it stores data as flexible JSON-like documents, which worked well for storing varied data like restaurants menus with different attributes and order histories. Express.js is a lightweight web framework that runs on top of Node.js. It's used to build the REST API, defining routes for restaurants orders, and recommendations, handling middleware like authentication and managing requests and responses. React is a JavaScript library for using the user interface. It lets you build reusable components like restaurant cards and menu items, manage state efficiently, and update the UI quickly whenever data changes. For example, when items are added to the cart. A Node.js is a JavaScript runtime that allows all the server-side code to run outside the browser, which means I could use JavaScript for both the front end and the back end. One language across the entire application. Implementation backend. Let's move into the implementation details, starting with the backend. I built the backend using Node.js and Express.js. I structured the project using MVC pattern, models, controllers, and routers to keep the code organized and maintainable. I defined Mongo schemas for our main collections: users, restaurants, main items, menu items, and orders, which handle validation and structure for the data stored in MongoDB. I built out a set of REST API endpoints, for example, endpoints to register and log in users, browse restaurants and menus, place and track orders, and fetch personalized recommendations. For security, I implemented password hashing using bcrypt, so plain text passwords are never stored, and I use JWT-based authentication to protect routes so that only logged in users can access their own orders and data. I also added middleware for things like error handling and request validation to make API more robust. Implementation front-end. On the front-end side, I built the user interface using React, along with React Router for navigation between pages like home, restaurant listing, menu, cart, and order tracking. I used React hooks like useState and useEffect to manage component state to fetch restaurant, menu, and recommendation data from the backend. When components load. For talking to the backend, I used to make HTTP requests to our REST API and handle the responses. I designed the UI to be clean and responsive, with a homepage showing recommended and nearby restaurants, a menu page to browse and add items, a cart and checkout flow. I also made sure to handle things like loading states and error messages. Implementation: AI recommendation system, AI recommendation engine. One of the most interesting parts of this project was building the AI-based recommendation feature. The goal was simple. Instead of showing every user the same list of restaurants and dishes, I analyze each user's past orders and preferences to suggest food they're more likely to enjoy. Integration and deployment. Once the front-end, back-end, and AI recommendation service were all working individually, the next step was integration, connecting the React front-end to Express back-end through REST APIs, wiring the recommendation service into workflow and testing each feature end-to-end. I also worked on deployment, hosting the backend and connecting it to cloud-hosted MongoDB using MongoDB Atlas. This step taught me a lot about real-world challenges like handling environment variables, costs, and keeping the recommendation service responsive uh, under real requests, challenges, and key learning. Along the way, I ran into a few real challenges. One challenge was managing authentication and order state securely. Another was designing the recommendation logic so it stayed accurate as more order data came in, and also learned a lot about debugging across the stack, figuring out whether an issue was coming from the front and back end database or the recommendation service itself. Live demo. Now let's take a look at the project in action. This is the back end, this is the front end. Now let's start the back end. The back end has started. Now let's start the front end. Now this is the food delivery app. Let's log out and then let's log in. We have successfully logged in. As you can see, these are the 9 restaurants. The one I created was the ninth one. This is the view review summary. Yeah, that AI has actually failed. I will look into that later. Now let's add some food like KFC. Let's add KFC chicken bucket, KFC spicy wings, KFC zinger burger. Now we have added the food to the cart, food in the cart. Now let's check out. I have used a Stripe checkout for this payment, for the payment. Let's fill the info. The payment is processing and the payment is completed. Now our order has been successfully placed. Go to the order. Here you can see we have added KFC. Now let's view. This is our order number, this is our information, and this is our payment paid. We have paid, and order status is processing. Now for the conclusion. To conclude, this internship gave me a practical hands-on experience across the entire web development lifecycle, from planning and architecture to building a secure backend, a responsive frontend, an AI-powered recommendation feature, and finally integrating and deploying a real working application. Thank you so much for watching my presentation. I'd like to thank the WSA team for this opportunity and for their guidance throughout the internship. Thank you.